Hey everyone, and welcome back to today's explainer. Have you ever looked at a premium car dashboard, or maybe a fancy luxury cosmetic bottle, and noticed that the color just looks different? It's not flat, it's got this metallic finish, or pearlescent shine, or even a deep marble effect. Well, today we are going to unpack exactly how everyday plastics get transformed into those incredibly luxurious items.
Here is our roadmap for today. We'll be covering 1. Beyond normal colors. 2. Pearl and metallic finishes. 3. Fluorescent and marble effects. 4. The glitter effect. 5. The science of processing. And finally, 6. Summary and next steps. Let's get right into it.
Section 1. Beyond normal colors. Let's set the stage by understanding the difference between standard plastics and premium luxury plastics.
I want you to think about this for a second. When you see that dazzling, premium finish on a product, is it made just with standard color pigments or dyes? Honestly, it's so easy to assume it's just fancy paint, right? But the answer is a massive no. To get that specific look, manufacturers use something called Special Effect Masterbatch.
And this comparison brilliantly illustrates the difference. A normal color masterbatch really has one simple job. Give the plastic a basic shade. Make it red, make it blue, make it black. You get the idea. But a special effect masterbatch, it's a whole different beast. Its entire goal is to create a premium appearance, visual attraction, and actual physical 3D depth and shine right inside the material itself. It's not just color, it's literal visual magic.
Moving on to Section 2, Pearl and metallic finishes. Let's see how this works for the finishes you probably see every single day. So whenever you spot that soft, luxurious glow on a shampoo bottle, or the sleek trim inside a nice car, you are looking at the pearl effect. It instantly elevates the perceived value of cosmetic packaging and premium household products, making them look high-end and sophisticated. But how does it actually work? Here's the secret. That 3D depth isn't just some clever optical illusion painted on the surface. It is literal light refraction happening inside the plastic. The magic ingredient here is mica-based pearlescent pigments. These microscopic mica flakes are embedded right into the plastic, and they both reflect and refract light, bouncing it around to give us that signature soft shine. Now, getting a metallic look in plastic is fascinating because it actually doesn't involve metal powder. Instead, manufacturers use carefully controlled aluminum flakes. You'll see this heavily in auto parts and electronics. But these flakes come with common problems, like really ugly flow marks, or the flakes shifting to the wrong orientation. The solution? It's pure physics. You absolutely need uniform flow, proper mold design, and highly controlled injection speeds, just to keep those flakes aligned perfectly.
Let's jump to Section 3, Fluorescent and marble effects. We are talking about two of the absolute boldest effects in the industry. If you've ever wondered why safety gear, sports equipment, and certain toys pop so intensely, this is why. Fluorescent pigments behave completely differently from normal colors. They actually absorb invisible ultraviolet light from the environment and emit it back out as visible light. So they aren't just reflecting color, they are literally emitting it. That's what gives them that super bright, high visibility appearance.
But as with everything in engineering, there is a trade-off. The huge pro is that you get this extreme visibility, which is absolutely crucial for safety in sports items, but the limitations are pretty significant. Fluorescent masterbatches generally have lower outdoor weather resistance and lower heat stability compared to standard pigments. They degrade a lot faster under harsh conditions, so manufacturers really have to plan around that.
On the completely opposite end of the spectrum, we have the marble effect. The objective here is to replicate the organic, elegant look of natural stone, which is super popular for plastic furniture and household decorative items. To achieve this, you have to use multiple color streams that flow together without fully blending.
And that brings us to the golden rule of the marble effect. If you overmix the material inside the machine, the marble effect is completely destroyed. You just end up with a muddy, solid block of color. Creating that stone look is a delicate dance of managing multiple unblended streams. If you over-engineer the mix, you completely ruin the aesthetic.
Section 4. The glitter effect. Let's look at a finish that is everywhere in fashion and beauty.
To get that gorgeous premium sparkle in cosmetic caps, fashion accessories, and gift items, manufacturers use specific polyester or aluminum-based glitter particles. These particles are physically larger and more rigid than standard pigment powders, which is exactly what gives them that beautiful sparkle. But because of their size, they require very specific handling.
And this creates a massive industry challenge.
If your glitter product feels rough to the touch or looks patchy, it's almost never a bad pigment. It's a processing failure. Common problems like particle breakage, uneven distribution, and surface roughness happen when the machine is just too rough on the plastic. The only way to solve this is through low shear processing, proper gate design in the mold, and selecting the absolute correct particle size right from the start.
Section 5. The Science of Processing. This brings us perfectly to the most critical part of our explainer today.
I literally cannot stress this enough. Special effect pigments do not behave like normal pigments. If you treat them like normal colors, you're going to face total manufacturing failure. The major risks: excessive shear forces, meaning the machine grinds the material way too hard, unstable high temperatures, leaving the plastic inside the machine for too long, or forcing it through an incorrectly designed gate.
Consider this real-world mini-detective story. Step 1. A cosmetic bottle manufacturer filed a huge complaint because the pearl effect on their bottles was completely missing. Step 2. During the investigation, engineers figured out that the machine's RPM was set way too high. The extreme shear force was literally breaking and pulverizing those delicate microflakes before they even reached the mold. Step 3. The solution was incredibly simple. They just lowered the RPM, processed the material gently, and boom, the pearl effect was instantly restored. The crazy plot twist here: the pigment was never missing, it was just being destroyed by the machine.
Section 6. Summary and Next Steps. That case study is a perfect example of why the science behind the scenes is just as important as the chemistry of the colors. Let's wrap things up.
We crossed off a massive checklist today. We explored how mica creates the pearl effect, how aluminum flakes give us metallic finishes, and how UV light powers fluorescent colors. We learned about the delicate non-mixing required for marble effects, the low shear handling needed for glitter, and finally, how crucial gentle processing is to keep all of these amazing physical effects intact. And honestly, this sets us up perfectly for our next explainer. Now that we know how these incredible materials are made and processed, how do we actually test them to ensure they are flawless? Next time, we are diving deep into master batch quality control. We'll explore MFI tests, ash content, dispersion testing, and how to scientifically measure color difference. You really won't want to miss it.
I want to leave you with this final, powerful thought to summarize everything. A premium appearance is never just about buying an expensive pigment. It's this delicate, precise balance between the chemistry of the material and the machinery that shapes it. Next time you hold a luxury plastic item, I guarantee you are going to look at it shine in a whole new light. But what happens when these delicate processes fail, and how do manufacturers catch it before a flawed product ever hits the shelves? Well, we'll answer that next time. Thanks so much for joining me on this explainer, and keep learning.
Before you leave, let me tell you something that every successful plastic engineer and masterbatch developer evaluate realize: anyone can make plastic. Many people can even make colored plastic, but very few people can create plastic that make people stop, look, and say, "Wow, that is the true power of Special Effect Masterbatch." Thinking about it for a moment, the pearl finishing on a premium cosmetic bottle, the metallic sign on an automotive interior, the glowing fluorescent safety product, the angled marble texture in furniture on the sparkling glitter effect on consumer goods. None of this happened by accident. Behind every stunning product is a scientist who understands pigment effect, additives, light reflection, polymer compatibility, processing condition, and formulation techniques. A small mistake in dispersion, temperature, or material selection can destroy the entry visual effect. The companies that master this technology don't just manufacture plastic, they create products that customers are willing to pay more for. That's how innovation becomes profit. So ask your one question: are you only learning how to process plastic, or are you learning how to create product that standing out in the market? If today's lesson help you understand the science behind pearl, metallic, fluorescent, marble and glitter master batch, then this is only the beginning. In the next episode, we will dive even deeper into advanced polymer formulation, real industry challenge, troubleshooting techniques and R&D secret that are rarely taught in classroom. Subscribe now, turn on the notification bell and become part of this journey. From learning plastic technology to become a true polymer expert. I will see you in the next video. Until then, keep learning, keep experimenting and remember the future belongs to those who understand not just plastic but the science that gives plastic its identity.